Hello everyone and welcome to this video on timing diagram of 8086 microprocessor. In the previous videos we have discussed on minimum mode and maximum mode configuration of 8086 microprocessor. So in this video we will be trying to discuss on timing diagram of 8086 microprocessor. So the timing diagram for minimum mode and maximum mode would be covered into this video. So I will be taking off any of the options like memory or IO, and I will be telling you how to change in IO if it is asked in a question of reading an IO or reading on a memory. How to change this one? There is a small variation in the diagram of timing diagram from memory read or memory write in minimum mode as well as in maximum mode. A little of variation of if you do it up, both this process should be covered to you. So for reference, we will be going for memory read operations, and you can go for memory write easily also. Now, what the changes you will be having over here is that, and next once we come for this one 8086 microprocessor, this is a memory read. So when you work on memory read operation, how this microprocessor will respond it up and how the read operation is being carried out, what are the different time durations, how the operations will be carried out in microprocessor internally without the interruption of any personnel, how it carries out, that is being shown in the time. And of course, when you see this one, different clocks, out of these clocks, the first one is an input clock, and we are taking some states as T1, T2, T3, then TW, that is nothing but wait states. TW is T wait states and T2. After completion of 3, if your read or write signal is unable to we will add on these wait states accordingly. One wait state or more than one wait states would be put up in this and let's start with the first one is that when in the first clock period, as you know that microprocessor when you have seen the minimum mode and maximum mode configuration, all the options have been carried out in that. In the first time period, let's say in the first clock cycle, in the first one, you will be sending an address I have match enable signal the high and address would be sent. Okay. Address would be sent. So that's the reason these two events, this high signal is being high for the first clock. And this time division is during the first clock period, the address in database, which is represented as AD0 to AD15, are just A0 to A15. Windows X, it would be acting as an address. Then A16 to A19 are the other four higher identity systems on this one. So come all together. A0 to A19 would be the 20-bit address bus defined. This one would be the address during the first half of the first block of it. So after immediately sending the address, the microprocessor stops sending the address and it would be taking some status information on all this one. So this status information from S3 to S7 are being represented along this. If you want the status signals of S0, S1, S2, you can refer it up when you are having it in the maximum. So this S0, S1, S2 are not having any signification in S0, S1, S2, not defined in minimum mode. These are there in a maximum. So that's the reason we'll be having the status information will be passed out onto this ring S3 and S7, which is common. So during the next period, it will be the status. After completion of the fourth class, again it is doing it as this is your And, say, after this one, again you will be sending the clock. So coming to this one, during the first clock cycle, you can see address is been sent. And after this one, at the half of their time period T2, microprocessor starts making the read signal to go low. When it goes low over here, the read operation will be started to take it up. And when it is going low, data enablement is also made for it. Data bus. So during this operation, during this one, read is getting low, and this is the data enablement is getting low. And this is the timing diagram for totally read cycle. So it is either receive or transmit the data. So when you are going for in the reference to microprocessor, nothing but receiving and handling. Nothing but receiving a data. Write is nothing but what? Write is sending the data. Receiving a data and sending the data. Transmit and receive. Data transmit. Write is nothing but sending the data or data transmit. Right. So transmitting a data from microprocessor is given by write signal. So here this is a read signal. So over the time it would be low here. Data receiving. This is a read signal. So this read state would be after that T3, it would be completely till T3, it would be going on. So here what I said is that during the after the T4, it may be going for completing the state over here, and it would be entering into uh, completion of the data. But if it is not yet completed, what it will do is that it will add some new states to the line. Some more read states and the programmation is a memory read cycle. Similarly, you will be having a memory write cycle. For memory read and memory write, the common thing is that this address latch enabled signal is high for the first clock period only. For all this one, memory read, memory write, read and write, and all this one, okay, the timing diagram for these three are obviously the clock will be the same. So the four are similar for all the timing diagram. Data enable is also the same point that the data will be enabled. So only the change will be there in this one. What is this? What is this? So if you remember these four, you can write this four. And, you need to remember biologically how to modify. So when you are going to read the data, there would be a small delay from coming from the bus to the transceivers to a microphone. Sending the data from the microprocessor is the same duration. Once it sends the address, immediately send the data. When the data into the microprocessor is instantaneous. So after the clock second, immediately it will started here. But when you go for the read, it's not starting at the second instant. And the value data, what is the data is there, it will be available, then that you will get power and fourth clock here. By the fourth clock here. You see right here. So here, the rate cycles may be increased. TW rate state may increase only when there is data is making up swing. And this is said, as this we told, data transmit and receive. When you go for data transmit and receive, when it is zero, it is nothing but reading it. This transmit writing it. This is the time cycle for your read and cycle and the minimum outcome. So here, this is transmit and receive, read and write. And when you go for the timing diagrams for maximum mode configuration, one thing you need to remember is that this one, you would be adding with the same line would be there, address latch enable address and that. These lines is the same. This is the three lines which are common. Okay. This one we can. Like we told in the previous time diagram, I told you this S0 and still S2 are not different in minimum form, but it is there in another mode. So their representation should be there. Here lines will be indicating one of these objects. Or it is like intertechnology. Among this one would be the values over this one. Supposedly, if I go for IO read off, what would be the change in here is that instead of memory read, we would have IO read. Suppose we are going for reading, these two lines would be the same. Only this line would be changed. Only memory read would be changed to IO read. The name itself we need to change. The everything will be the same. So once again, we'll be going for discussion on this one. And here, you know that when the maximum mode, we can have the maximum number of reference and you read or you read operations will be there. And here, one more thing can say, here we can add one more time diagram like at the bottom we can maybe make use of memory or bar. And this is the memory operations we can signal as high throughout the relation timing diagrams of the instrument. So indicated it is an memory operation. If it is not, it is an IO operation. So that would be done. So this is the circuit, whether just for read operation, write operation, all these ones would be equal to status lines x0 and s1. Then data transmit, it is the read operation, it is the receiving of data. It is the receiving of data. When we do that, what I want to do was that looking at that, write the data. So here, this is the memory right side of the memory. Uh, so I have shown you what is memory or this is the memory name. I can say it is a memory or IO. It writes like timing diagram in maximum. So when you go for the IO right or memory right timing diagram, the only the change is that this one name will be indicated. Remaining part same. First of all, these are near gate view, possible menu, configuration, menu configuration, all these are the same thing. You can across daily address status line, address the same. When the change is that data speed or the same. And because for read data, the throughout operation, data speed is high. This is every time it is high. We have to so it is high evidence. And that I enable the things. It's about the real read or write cycle and remember this one. These are the different eight different operations. Right? I have to now say, really to be thank